Hi there, this is Ryan Malloy here at the Worldwide Center of Mathematics. In this video, we're going to discuss what are iterated fractions. So, to start off an iterated fraction, we'll use some constant, we'll say a0, or a sub naught, plus a fraction, where the denominator of this fraction will be an expression that looks very similar to what we already have, of a1 plus 1 over, same thing. We just keep going like this. Until eventually, we arrive at our final constant, which we'll call an, where all of the an's are simply natural numbers greater than 0. So 1, 5, 17, so on. Okay. Now, there's a very natural way of expressing this in a much shorter notation, or more compact. We simply put in our first coefficient, a0, followed by a semicolon, and then we just list off the others. a1, a2, a3, and so on and so forth until we get to an. Now, in some cases, this process will continue to infinity, so we won't have a final coefficient. In that case, we can simply end this notation with the ellipses. So a natural question is, why would we ever express a number in this way? It seems very counterintuitive. And for a lot of numbers, it is an extremely bizarre and unwieldy way of expressing things. But suppose you take some irrational number, like the square root of 2. If you were to express this in a traditional decimal notation, you get approximately 1.41421356 ... because that's all I've memorized. There is no pattern to these numbers. If you want to express this out to 50 digits, you simply need to memorize all 50 digits, or look at a calculator. But there's a very natural way of expressing this with iterated fractions. Here we have a0 is 1. And then each of the other coefficients is simply 2. So that notation would be like this. 1, 2, 2, 2, 2, and so on and so forth. And if you take the limit of this process, as you add infinitely many terms, it becomes square root of 2. My name is Ryan Malloy, and we've just discussed what is an iterated fraction.